Welcome everyone to JTAC's Clarity 2.0 software webinar. My name is Justina Valencia and I'm part of the marketing group at JTAC North America. On the line we have our presenter Chuck Barber, who is our Director of Product Management at JTAC. At today's webinar we'll review what Clarity is and highlight its features via live demo to show you the software's ability to match patterns, decode barcodes, detect presence or absence of an object or objects, among others. We'll also go over the newest updates to the software, which include the ability to match color and pre-process images. We encourage you to type in any questions you may have into the chat window during the webinar so I can read your questions to Chuck at the end of his presentation. We'll do our best to answer all of your questions. However, if time does not allow it, we will email you back the answers to your questions. So now, without further ado, I'd like to hand the mic over to our Director of Product Management, Chuck Barber. Chuck, take it away.
Okay, thanks, Justina. I'm going to get right into it here. I'm sorry, I'm having a little trouble. There we go. Okay, so this is my bio on the page here. You can see it's my picture. Really, a lot of this sums up to me that I've been around for a long time. I've got about 31 years of experience in technology fields, about 20 years of experience in the automatic data collection industry. So we would define automatic data collection as technologies like barcode reading, machine vision, RFID, and so on. I've been here at JTAC for 8 years, and I have a bunch of patents all around image-based technologies, the kind of things that we're talking about today. So this is our agenda for today. I'm going to start out a real brief introduction to JTAC to tell you really who we are and where we come from, and then we'll get right into the meat of the Clarity presentation. Okay, JTAC is a company. We're based in Syracuse, New York. You can see here on the map we have an office in Breda, the Netherlands, and a couple other smaller offices around the field. These are the technologies in which JTAC is engaged, and it's really all OEM kind of components that we sell primarily into the medical device industry. What we're going to concentrate on here today is our machine vision products. We also do a lot of work in 1D and 2D barcode reading, RFID, and we have a business in spectroscopy and printers and strip chart recorders. We've actually made a few acquisitions over the last several years. We have the general scanning printers, which is our printer technology, photo research, which is our spectroscopy technology. And over the last year and a half, we've acquired 2 RFID companies, SkyTech and ThingMagic. And we have several RFID webinars available on our website if you're interested in that technology as well. JTAC is actually part of a larger company called Novanta, which is headquartered in Bedford, Massachusetts, out near Boston. And there's 3 main product groups, as you can see here, as part of Novanta. Novanta really came from this kind of product, which is galvanometers. If you think of a laser that shines on a mirror and with a motor to precisely steer that mirror and steer that laser beam. That's really the kind of technology that really Novanta started with. We have here our precision motion group with Solera being the main company there. And if you can think about motion in terms of things like robotic motion, moving a robotic arm very precisely. So maybe some small high precision motors, and that goes along with those motors some sensing tech equipment so you can sense very precisely where that arm is actually moving to. There's a third company called Westwind, which they make high-speed, high-precision drill bits used to drill all the vias and printed circuit boards. JTAC's here in the Vision group within Novanta, along with NDS, which makes high color fidelity displays for use primarily in the operating room. And then they have a series of embeddable displays. I always characterize these as, think of a tablet without the case that you can take and embed into an OEM product. Okay, that's enough of the background. We're going to get right into Clarity 2.0 and tell you about that. So what is Clarity? Clarity is a machine vision development software that can be used by a user with you don't even have to be a software engineer, and definitely you don't have to be a machine vision engineer to develop a machine vision application. So here's an example application here that I developed quickly, is where you would, we're finding the two edges of a test tube and measuring the distance between those two edges in order to determine the size of that tube. Clarity is a PC application. So what you would do is you gather images and you develop this machine vision application on the PC using Clarity, and then you can download that application into a JTAC camera where it would run on the camera going forward. We'll talk a bit more about that development process later. And really the idea here is Clarity will remove some of the mystery from machine vision so that, again, anyone with some reasonable technical capability, you don't have to be an engineer even, but definitely not a software or machine vision engineer, and you can develop a Clarity machine vision application. We'll go through some examples later on. Okay, so this is Clarity, and we're going to concentrate on, I'm going to walk you through the screen here. This blown up area here is what we call our plugins, and these are all the different Clarity functions that are available. I'll walk through those in a bit. So that's this area of the screen here. Through the development process, you're going to string these functions together to get a step of what we call the script, which is the steps through which the machine vision algorithm is going to walk to do its job. We have an image display area here. Again, how you would work with Clarity is you'd gather these images, you'd develop the machine vision application on the PC, and then flash it into the camera. And then each of these plugins, these specific functions, has different adjustments that show up down here. And again, we're going to show you some examples of that later on. Our first plugin is our PresenceAbsence plugin, and that really does just what it says. You use that to determine if something's there in the image or not. Here's a quick example I did showing a test tube, and I'm using this area to detect if the cap is present on the test tube or not. Our count function, also often called blob counting or glob counting, glob detection, is used to find things in the image. You're not going to identify them by shape necessarily, but you just by size and by contrast, you're going to say there's a certain number of objects there in the image. In this application, I'm counting some pills, but it could be applied to manufacturing parts, screws that are in a tray, or any number of things. Pattern match gets a bit more specific, where you're looking for a specific pattern, a specific shape in the image. In this case, we were using a pattern match to look at a biopsy shape and to match that shape to a slide, a slice of that biopsy that's been put on a slide to make sure you're matching the right biopsy to the right slide. Good old barcode decoding on this plug-in here, and this is an example where I've set up a window to decode this particular barcode. And it's a little harder to see in this image, but you could have multiple windows set up to decode all 5 barcodes in this image in the right order and output the data so that you know which barcode matches to which data. This slide I've lumped finder and measure together. They're usually used in conjunction with each other, where finder is going to be used to find some kind of a shape like a line or a circle or a corner, and then measure is going to be used to measure the distance between two of those more primitive shapes. Again, the example I used previously was finding the line at each edge of this test tube and measuring in between them. We have 2 brand new plugins in Clarity. We have our image processing plugin, and how that's used is to somehow modify an image in order to make one of the subsequent machine vision steps work better. Here's an example where we have this barcode, a data matrix barcode, and this finder pattern was broken here, so we used our pre-processing to clean up that finder pattern to make the barcode decoder's job easier to do. I'm going to show some other examples of that pre-processing later on. And then the biggest new feature is color detection. And this is a case where it does just what it says, much like the other Clarity plugins, where you're going to look at some area of the image and you're going to deliver off to the host application what is the color of that object. what does a clarity project look like? Well, just like any engineering project, you're going to start out with your system design. And it's like any project, you need to get that basic foundation down of your system design before you proceed. So what's camera resolution needed? What's the distance of the camera from the target? What kind of lighting works best? And so on and so on. But once you have that done, usually we're going to develop some kind of mock-up of your system, either a test fixture or you get the actual system yourself. You can install your camera, gather images, and then these green steps here, this is where clarity comes in. You're going to put those images on a PC, and you're going to take clarity to operate on those images to set up your machine vision algorithm. That machine vision algorithm will then be, we'll call it a script. It gets flashed into the camera. And then after that, you can run the system right on the camera, right in your host device. And really to see what your results are delivering, what you need, and then you repeat these steps as needed in order to make sure you're getting the machine vision results that you require. We often get a question, could clarity be used with a third-party camera? So as I've talked a couple times previously in this presentation, clarity is designed to be flashed into JTAC cameras. But there's no reason you couldn't have a system like this where you had a camera that's shipping an image to a host PC of some sort here. The development process would look much the same, where you'd gather images using that camera. You would develop your machine vision script with clarity. And then our engineers would have to work with yours to adapt those scripts over to the processor and operating system on this host processor. And after that, it would work, the clarity and the machine vision would work in your system very similar to the way it would work on a JTAC camera. Okay, now we're going to switch gears a little bit. We're going to talk a little bit more about the specific features of clarity and do a demo. I'm going to switch over. I have a video that we're going to present where I've walked through some a bunch of the different plugins in Clarity to configure a machine vision script. I do want to say ahead of time that sometimes with the over the WebEx system, the image quality may not be great on the viewer's end. Just rest assured, we'll make high quality versions of this video available after the webinar. Okay.
In this video, I'm going to try to illustrate as many of the features of Clarity as I can in the limited time that we have available. What I have here is a test fixture that we use at JTAC, and it's a simulation of a lateral flow diagnostics reader. If you're not familiar with lateral flow diagnostics, but they're generally if you think of an early pregnancy test, that's a good example. So you're going to have some kind of a cartridge that you put on blood or urine, some kind of bodily fluid, which then will react and generate some kind of line or some kind of symbol on the cartridge. The cartridges usually have a reference area like this, a reference color, and then they have the reaction color, which shows up if the reaction is positive. And that reaction color can be brighter or dimmer, as I've shown here in this simulation. This first image is just the background in the test fixture that we use. And I think I'm going to start there, and I think the first thing I'll show is our presence-absence step to see if the cartridge is even present in the image. So we're going to add our presence-absence step. Now the first thing you see is you get an invalid image. Well, since I was using color images here, but this step requires a black and white image. So I'm going to add an image process. We'll move that to before the present step. And then in my image process function, I'm going to say convert to grayscale. Now my present step, I'm going to go down here and I'm going to say, well, what image do I want to process? I can use the acquired image or I can use the image processed image. Now you see that error goes away. Now we can actually begin to work on our presence absence function. This red box, this region of interest box, shows up on the image, and I'm going to move that to the area of the image that I actually want to process. This is the area of the image where I actually want the machine vision to do its work. Well, I notice that I have these bright pixels here in the image, and I'm going to try to detect those bright pixels, which should go away if the cartridge is present. Okay, since I'm only interested in the bright pixels, I'm going to use these selections. I could either slide or just type in directly to say only look for pixels that are between a value of 255. This is an 8-bit image, so any pixel value can take a value from 0 to 255, and I'm only interested in those very bright pixels that are up at the high end of that range. Then the next thing I'm going to do is, you can see I have about 10,000 of those bright pixels in this particular image, or in this area of interest I should say. So I'm going to say I only want it to be a pass if I only have a very small number of those bright pixels, say between 0 and 100. So let's see how that works on an image where there's actually a cartridge. Now you can see I had 0 bright pixels, and so that's a pass. Again, a pass, a pass, a pass, and back to my original image. So that worked pretty well. Next thing I'd like to do is illustrate the use of pattern match. And I'm going to use pattern match to recognize this logo in the image. A lot of our customers have a kind of business model where they have a device they sell, but then a lot of the revenue stream comes from the cartridge or whatever disposable goes with that device. A lot of times they want to recognize the logo to recognize that it's actually their cartridge that's being used there and not a counterfeit cartridge. So we'll click on the pattern match. Again, the first thing that happens is I get this train image box that pops up, and I have this green area image that green area of interest that I'm going to move over the feature in the image that I want to recognize. So we'll move that around the logo, and I'm going to accept it. Now back to the original image, this box is the area of the image where I'm going to look for that particular pattern. You could make that the whole image if you want, but in a well-controlled position situation like this, you would only need it in the particular area where you expect that logo to show up. Now you can see I had a 100% pattern match for that logo. That's because I'm comparing the trained image to the actual full image from which it came, so I'm getting a perfect match. But in subsequent images, you can see that goes down a little bit, but still a very good match. The next one matches. Now this last image, I doctored up that logo to make it look like it's counterfeit, and you see my pattern match score drops, and with the red border on this step and the red border here in the image indicates that that step now failed, that pattern no longer meets our criteria. Now I could change that. I could change my passing score up or down depending on how loose or tight I wanted that particular pattern match to be. Next, let's try a decode function to decode that barcode. So I'll add the decode, and it's taking the image process step, which is what I want. Again, I get my region of interest. I'm going to move that around the barcode. And as soon as I move that around the barcode, you can see the step went green because the decode process saw a valid barcode, and this is the message that's inside. I have a whole lot of other settings here. I have all these linear codes, which again, in this application, I never expect to see those, so I would probably turn those off. A bunch of 2D codes. I'm only have this Aztec code, so I'm going to shut those off, and so on. And there's a lot of other settings that are described in our online help and in our other videos that are online where you can see a bit more about how these work. Okay, the next thing I'm going to do, let's actually run that through the other images to make sure it decoded on all of them. And that all worked. The next thing I'd like to do is actually start processing these colors on this lateral flow diagnostic strip. So I'm going to add a color detection step. Well, because I had this step selected before, it put it right after the step I had selected, but I can just move it easily down here. Okay. Actually, before I do that color match though, let's do something different. Let's use our finder I can show you how I can find that line in the image. Zoom in on that a little bit. So this is my region of interest here. And you can see it's a little different. It has an arrow in it. Well, I'm going to try to find this line. And actually I've got find line as the default set for the finder. What this arrow signifies is that the algorithm is going to search in this direction through the image till it finds a line. And you can see it found this edge line right here. But since I want to find this horizontal line, I'm just going to move this that way. And then let's move that to our line. I'm going to change my polarity of the line. I'm looking for the line to go from white to black. Let's change that. I'm going to tighten this area up a little bit. And you can see I've got a good find here, 100% match on that line. Okay, I'm now going to clone that step because I want to find the other line as well. I'll move my color match down below. Let's go to an image where I have a line for the reaction area. I'm going to move my region of interest down there. And you can see I found that line as well. Let's make it a little easier on ourselves. We're going to change this to reference line, and we'll make this one reaction line. And then let's show how we would use our measure function to measure the distance between those two lines. How the measure function works is it can take any of the previously found parameters in the image, features, and measure between them. So you can see I have my pattern match, which was my logo, my decode, or the reference and reaction line. So in this case I'm going to say let's measure between the reference line and the reaction line. You can see my measured distance went to 322, and then this blue line here, we can zoom in a bit more, shows how it measured between the two. I could change the angle on that line by moving these regions of interest to be more in line with each other, more aligned. That would be a little bit better. Okay, now let's get back to my color match, which I started a few minutes ago. So I go to my color match step, and again, just like the other steps, I have a region of interest here that I'm going to move down, and I'm going to modify that region of interest to be as tight as I can around that red bar as I can. And that's because I only want to capture that red color if I can. I don't want to capture the other background color. Then I can go to train color. You can see this is the color right here that it's recognizing, the dominant color in that box. I'm going to add that color to my list, and let's call it reaction color, and close. Okay, now that has established my reaction color. Let's go through the previous. That was my original image. Now here's something interesting. You can see that this area of interest moved because the position of the line in the image moved slightly from the first image to the second image. And you can see that that's a bit of a problem, but I can correct for that. By setting I can anchor. Actually, let me go to the other image. I can anchor this window to the reference line find. Now that area of interest should always be over this line because I'm anchoring it to the line step where we found the line. Let's go to the previous. As you can see now, the region of interest stays on top of the reference line. I'll go to the next, and the next, and the next. So that's good. That stayed on the line like we want it to. We'll go back to our original image. And just like I did before, I'm going to clone that step. Let's go here. Okay, my clone step, now I'm going to move the area of interest down to the reaction line. You see I have a good match here of the reaction line to the reference line. And let me run the next one though, where I dimmed out that reaction line a little bit. And you can see I get an unknown color because this color departs from that reference color a little bit. But I do get the color distance. And the next one should be an even higher color distance, which it is. So through the project development process, what we would do is use a variety of these different strips with the different reaction colors to determine where is that breaking point, where's the spot where we actually should call that a positive result, and then we could set the color distance to match where it would be positive or negative. Okay, the next thing I should show you is we haven't actually added any output to this script. The output would be really how you want to communicate your results to the host system. So here I'm going to have the output. Now you see you get all these pop-ups, and I can get an output from any of the previous steps. And in fact, I could sprinkle output steps throughout this script. So I can select a few of these things. I think I would probably want to add maybe that I found the cartridge first. So I'm going to add text to the output. Now this is just a free text string. I'll use a little shorthand, cartridge present, space. Well, that was in my present step. I can add the result, add to the output. So now the actual output will look like this, cartridge present, true. In this case, we did find the cartridge. Well, I'm sure I would probably want the barcode decode result, so let's add a little text for that. And I'm going to add barcode. Decode message. And there we go. We have barcode, and this was the barcode message. And really along those lines, I could add any of these other steps. I could add, I'm sure I would want to add by color distance. So for my color match, again, I would probably add a text line. I'm not going to do that again because I think you get the idea. But I'm going to add this color match clone and color distance and add that to the output. and so on and so on. I could add as much or little information as I wanted to for the script. One of the things I didn't show you was this count function. And that's really because I couldn't think of a good way to make count make sense with this lateral flow diagnostics example. So I'm just going to grab another image that I have on my hard drive. And that's an image of some pills, as you can see here. And I'm going to use the count function, so we'll add that to the end. Oops, well, it added it way up the beginning, which is okay. I can work on it right there. It added to the beginning because I had last selected this acquire image step. Well, just like with the other plugins, I get my region of interest. I'm going to set that up around the area in the image where the objects are that I want to recognize. Well, you see right away I get all this little noise pops up where the algorithm is detecting just slight illumination variations in the image. I can change some of that. I'm going to go to an adaptive background threshold where now the threshold used sort of adapts across the image for those lighting variations. But I still get a couple of them in here, as you can see. Well, what I can do is use these sliders to set a region of interest for really the amount of area that the objects I'm looking for will cover in pixels. So really, how big are the objects I want to see? Well, you can see I changed those, I moved those up higher, and right away I recognize all these pills. And I'm recognizing from about 30,000 pixels to about 72,000 pixels of coverage for those objects. What I'm going to do is I'm going to move this a little tighter. 46,000 I still recognize. Okay, 54,000, I start to lose them. So let's move this up to somewhere in between there. 54, 51. And then I can move this down as tight as I wanted it to be for however discriminating I want to be for the size of those particular objects. Well, that demonstrated all the different plugins here. There's one other thing that a very powerful feature of Clarity that I did want to show, and that's this test function. And if I go to the test screen and I hit start, what Clarity does, it runs through all the images. Now I only had 6 images here, but it ran through all of them, and it's going to give me the result of every single step along the way for every one of those images. I could then take all this data, I could put it out in a comma-separated variable file, and I could process that in Excel or a similar program like that. So with 6 images, that wouldn't probably be so necessary, but in a typical machine vision project, you're going to end up gathering hundreds of images or even thousands to see all the different variations in the images to make sure that you get the results that you want. So this is a very powerful feature of Clarity that helps you test all the different variability that you might see on your input images. Well, that concludes our video. I hope this illustrated how you can quickly implement a simple machine vision project, or you could string plugins together to do a more complex kind of machine vision routine using Clarity. And we hope that you would give us a call if you see any need for this kind of capability. Thank you.
Okay, thanks. I hope that was illustrative of how you could use Clarity. I apologize. There's a few spots there where the voice was a little bit out of sync with the video, but hopefully, again, you get the idea. And we're more than willing to consult with you if you have a project to see if Clarity will do what you need. I want to finish up with just 2 or 3 slides. I have a few case studies that show how we've used Clarity to execute actual projects for different customers. Well, first thing, this spectrum here sort of shows really the range of machine vision projects, the way that you can execute a machine vision project. You know, on one end, there's a full outsource. So we'll get some customers that'll come to us and they'll say, we don't know anything about machine vision. We don't have the resources to execute a project, and they would like JADAK to do the whole thing. In that case, we'll, of course, quote the whole job, and we'll do that whole project. And at the end, we'll deliver Clarity along with that script to the customer so then they can run with it going forward if they have to make changes down the road or in the future. On the other end, we'll get customers that say, boy, I really just want to do it myself. Deliver Clarity to me. Maybe we'll do a little bit of consulting up front, some training for sure, to train them on how to use Clarity. And then the customer will run with the project from there. They'll develop the whole machine vision script, gather the images, do all the testing, and do the whole project on their own. What we're seeing more and more is this middle ground here, where we'll get customers that will come to us and say, boy, I really want to do a machine vision project. I like the idea of using Clarity, but I don't really know how to get started. They have no experience with machine vision, so they say, JADAK, can you get me set up? Can you do the upfront system engineering, get things started, maybe even develop the initial script and do some initial testing? But then we want to take it from there so that we can have that ownership and so we really can know what's going on inside of our device. I'm going to give you a little case study of each of those different scenarios I just walked through. So the first one we're going to start with over here with the do-it-yourself. This is a customer that they were making an automatic slide sortation system, and they needed to recognize a rack like this and were there 4 slides in it or 3, or were there any missing? They didn't want to have their robotic pickup go to a position where there was no slide. So this is a case where we delivered Clarity to the customer. One of our system engineers actually visited them and gave them some training and helped them get set up. And then the customer ran the whole project from that point on going forward. When the project was all done, they actually sent the script to us, and on our production line, we're flashing that script into the camera so they get cameras on their production line that are all ready to install. This next example, this is that middle ground where JADAK did part and the OEM did part. The graphic here, this shows a Chinese hospital, and I think everybody knows there's a lot of people in China, and these lines in this particular picture are just people waiting to give blood. So they're sick for some reason, they have to give blood for some reason, and so the lines are long. So our customer was trying to automate that process and to streamline the process, to be a better way to say it. So they were making an automatic tube sortation system. And how the test tubes work, depending on the color of the cap, that can signify the kind of test that needs to be run in the lab down the line. So they made an automatic sortation system, so a nurse would just put in what kind of test and that would deliver that particular tube to them. Well, this customer was one of those, they weren't comfortable getting started. So what JADAK did is we did the upfront system engineering. We actually developed a test fixture where we installed a camera, installed the test tubes, developed that initial machine vision script, and then we delivered that system to the customer, trained them in what we had done, and then they finished up the project. So they gathered thousands of images to test all the different variabilities that they might see, as I talked about before, finished up the project, and did the rest on their own. So it helped them get started with the system engineering, but then it gave them the ownership of the final project. This last scenario would be where JADAK did the whole thing. We developed a turnkey solution to the customer. This is a simulation where they had a reagent pack detection is what they wanted to do, and they wanted to detect in their system, is the reagent pack there or not, and is it fully seated in the slot where it's supposed to go. So JADAK developed that whole application, developed the initial system engineering again, developed the scripts, gathered all the library of images, did the full testing, and delivered the whole system to the customer when they're done, along with the machine vision script so that they could work it going forward. That's really the end of our introduction to Clarity 2.0, and then we're ready to take questions now if there are any.
Okay, Chuck. We did have 3 questions come in during your presentation. One of the questions that came in is, which cameras is Clarity compatible with?
Okay, as I mentioned before, Clarity is meant for the script to be flashed into a JTAC camera, although for a third-party camera we could discuss and we'd be willing to consider making it work with a third-party camera as well. For the JTAC cameras, if you got on our website and you wanted to look, there's our FM5, our FM6, our SC6, and our Vibe camera platforms that are all Clarity compatible.
Okay. How do you get a script from a PC to the camera?
Oh, good question. Well, we just did a quick demo of how I developed the script on the PC. There was one thing I didn't show in Clarity. There is a button, a device button, so you can take your actual target camera, connect it to the PC, and then you select that device, and then there's a selection to just flash the script into the camera. And then after that, you can test in an online mode where you're testing directly in the camera. And like I said earlier that we did in one of the case studies, once the script is complete, JTAC can actually flash that right into the camera right on our production line. So if you were buying a JTAC camera, you'd get it every time with your script already flashed in.
Good. Does Clarity work on other applications that are non-medical?
Well, yeah, as I mentioned a couple times through the presentation, JTAC's business is primarily in the medical world, delivering to medical device manufacturers, but there's no reason that Clarity couldn't be applied to other industries and manufacturing or any industry really where you just want to apply those machine vision tools to solve some kind of problem.
Okay. We did have one question come in regarding not being able to hear the audio on your video, so rest assured we will follow up to ensure you're able to hear and view Chuck's demo. With that, this concludes our question portion of the webinar. At this time, I'd like to thank all of our attendees for joining the webinar, and a special thanks to our presenter, Chuck Barber, for his presentation and demo. A recording of this session will automatically be emailed to those who registered for the event within the next 24 hours. If any of our attendees have any further questions on Clarity software, machine vision, or any of our other technologies, we invite you to visit our website, jadaktech.com, or schedule a tech day with us by emailing us at techday@jadaktech.com for a free technology consultation. Thanks again for attending, and have a great day.